Hello, this is a brief explanation about hyperbola. A hyperbola is a conic section that results of a cone being cut by a plane parallel to the axis of such cone. The hyperbola has several parts that we need to calculate before we can graph it. Our hyperbola is only this blue graph. Everything else is something that we need to calculate and place in the Cartesian plane for us to graph the hyperbola. The first point that we need to calculate or we need to place is the center. Here it's named S. It has coordinates h in x and k in y. Next, we need to place the vertices. The vertices are only the only 2 points that are part of our graph, the v1 and v2. Everything else is apart from the graph of the hyperbola. We need to calculate also b1 and b2. We need to place these 2 points that are the co-vertices. And these 2 points, f1 and f2, are the 2 foci. The distance between the center and each one of the vertices is called a. The distance between the center and each one of the co-vertices is called b, and the distance between the center and each one of the foci is called f or c. In this case, we're going to call it f. The standard equation of a horizontal hyperbola is x minus the x coordinate of the center, which we called h, squared divided by a squared, minus y minus k squared. K is the y coordinate of the center divided by b squared equals 1. Let's remember that a is the distance between the center and each one of the vertices, and b is the distance between the center and each one of the co-vertices. For this example, we have a center in 1, minus 2. The distance a is 2 and the distance b is 5. So in order for us to write the standard equation of this horizontal hyperbola, we just fill the places we can fill out from the standard equation that we have here. Then, for this example, we have that the first part is going to be x minus the value of x in the center, which is 1, x minus 1 squared divided by a squared, which is 2, squared is 4, minus y minus the value of y in the center, which is minus 2, so it's going to be plus 2, squared divided by 25, and that is equal to 1. If we want to graph this hyperbola, we need to remember first that our center was 1, minus 2. The distance a was 2 and the distance b was 5. Then we need to calculate the distance between the center and each one of the foci, which we called f. The formula to find f is the square root of a squared plus b squared. So f is going to be the square root of 4 plus 25, which is the square root of 29, which is a number around 5.385. So for us to graph, we need to place all the points that are important here. First, the center, 1, minus 2. 1, minus 2 is around here. Then, the vertices. The vertices that are at the distance a from the center. Since it's a horizontal hyperbola, it's going to be 2 places left and 2 places right from the center. This is the center, this is the vertex 1, this is the vertex 2. Then we place the co-vertices. The co-vertices are at distance of 5 from the center. So we go 5 places up, this is the co-vertex 1, and 5 places down, this is co-vertex 2. Using these points, we're going to draw a little rectangle that passes through all the 2 vertices and 2 co-vertices. Then we're going to draw asymptotes that go through each one of the corners of this little rectangle. So this is one of the asymptotes. This is the other asymptote. Asymptote. And asymptote. Then we need to place the foci. They're going to be at a distance of around 5.385 from the center, so we place the point there. The center, and we count 5.4 more or less from the center right, 5.4 to center left. Why right and left? Because it's gonna be a horizontal hyperbola and the foci must be always inside of the hyperbola. Finally, we need to know how much it will open the hyperbola to each one of the sides, so we need to calculate something called the latera recta. The latera recta is the opening of the hyperbola at the foci F1 and F2. The latera recta has a formula of 2b squared divided by a. That means that the latera recta is going to be 2 times 25 divided by a, which is 2. So it's going to open 25 units in total. That means that at the height of the foci, you're going to go 12.5 places up and 12.5 places down. It means that here, from the foci up, this hyperbola is going to be 12.5 places up and 12.5 places down. So it's going to open like this and like this. Then here and here. It's a little bit ugly, but this is how it's graphed, more or less, using the asymptotes, the vertices, which I didn't touch here, but it must touch it, and each one of the foci. The distance here up is going to be 12.5 units, and down 12.5 units. And we need to know and remember that the hyperbola never touches the asymptotes. The hyperbola gets closer and closer to the asymptotes, and it follows them to the infinite, but they never touch each other. We're now going to find the general equation of this hyperbola. To do it, we're going to use the standard equation. We're going to transform this standard equation into something like looks like this. Ax squared plus by squared plus cx plus dy plus e, and everything must be equal to 0. So we're going to solve these squares, and then we're going to transform this into this. The rules that apply to this general equation are that a must be positive and all the coefficients must be whole numbers. So we are going to solve first we're going to eliminate the denominators by multiplying times 100. That transforms this 4. We eliminate it, and this becomes 25, because 25 divided by 25 times 4 is 100. It's going to be 25 times x minus 1 squared minus 100 divided by 25 is 4, so it's going to be 4 times y plus 2 squared equals 100 times 1 is 100. Then we solve these squares. 25 is going to multiply the solution of this square. The square, we apply the formula of the square of a binomial, so it's going to be x squared minus 2x plus 1 minus 4 times the solution of this, which is going to be y squared plus 4y plus 4, and this is going to be equal to 100. Then we're going to multiply this 25 times the solution of the x minus 1 squared, which is going to be 25 times x squared is 25x squared. 25 times 2 is going to be 50x, then plus 25 times 1, which is 25, then minus 4y squared minus 16y minus 16, and that everything is equal to 100. And then we're going to pass this 100 to the other side of the equation. We're going to add everything that can be added, and we're going to go and write this equation in this form. So we're going to write first the x squared, 25x squared, then the y squared minus 4y squared, then the x minus 50x, then the y minus 16y. Then we're going to add all the constants. 25 minus 16 is going to be plus 9, minus 100 is going to be minus 91, and everything is equal to 0. This is the general equation for this hyperbola. A vertical hyperbola, we do the same. We just place everything in the place that is correct, and that's it. For example, here, if the center is minus 3,2, we're going to write y minus the value of y in this vertex, which is 2, minus 2, squared, divided by a squared, which is 9. Then minus x minus the value of x in the center, which is minus 3. We write it plus 3 squared divided by b squared. B squared is 1 squared, which is 1, so we write it like that, equals 1. And all the rules that apply to the horizontal hyperbola apply to the vertical hyperbola too. Just the difference is that the vertices are now up and down from the center, also the foci are up and down from the center, and the co-vertices are left and right from the center. Thanks for watching this video. I hope it was helpful for you to understand a little bit more how to graph and how to find everything from the hyperbola. Thanks a lot.